Hello, welcome to the third in the series on the material database. In this tutorial, we're going to talk about how to load the database from Excel. So as far as why use Excel, if you have a large number of materials, and say you have an existing material database, if you can export that material definitions out into Excel in some way, then using the loader, the Excel loader, would make a lot of sense. So we're going to talk about how do you find this Excel workbook. It's called materials.xlsm, and then how to execute the loader. And then we're going to do a walkthrough of the code, because odds are when you do the export to Excel, it's not going to line up exactly with the material, the property names, and the order things are in. So there's going to take some editing of the spreadsheet, or the VBA that's in the notebook. So let's begin. Well, the first thing we need to do is find the Excel workbook. So we go underneath to where it's installed, and by default on a 64-bit machine it's going to be on programs x86, and we'll go down to Structures Office, and underneath there you will find a Documents folder, and there's the materials.xlsm. So if you're on a 32-bit machine, there is no x86, it's just program files. But see, Program Files, Structures Office Documents. Open that up. And now here we're going to, you have to set, where is the SQL database, the SQLDB file that you want to load. So you've got to set, first off you've got to get this path in, get that correct. Then it's just a matter of clicking the loader, and it tells you, yeah, I'm loading that database, which is the one we created in the tutorial. And then it says, do you want to clear the database? There's two options. You can leave what's append to the database, or wipe it all out, start clean. I'm just going to append. So what it just said was I created a mat3 and mat4 with these obviously dumbed up values in the SQL database. So let's go check. Let's go to the command, and let's do our friend SQLite 3 and .open structures. And then let's do a select names from, and we'll see there's the 3 that we first created, and then the 2 new ones. Well, or these are the 2 new ones. These were the metal 1, metal 2 were already there. So we added these dummy values, mat 3, mat 4. And you can see the names for each of the properties across the top that correspond with the table names. And the schema shows you every field in that table, every column, and what its data type is. And you'll see that these names match up with these names. Well, they will underneath when we get to the Visual Basic. So let's take a look at the VBA. So let's get out of there, and now we're back into Excel. We were in Structures Office mode there. Clicking outside brought us back to Excel. Now we go to the developer. If any of this is unfamiliar, you need to see there's a series of programming with Structures Office that you'll you need as a precursor to this. So I'm going to go into the Visual Basic portion. Okay, so when we click on Load Materials, it's going to execute this function button script click, which calls Read Materials. We can find Read Materials here. And so there we are. This is the standard code that you saw in the tutorials of finding the embedded Structures Office object. And then we put up the message, which we're loading. That's row 3, cell 3 is the name of the database that we're using. That's just a message. And then we ask, do you want to delete the materials? If that's a yes, then it will call the delete all materials function, which wipes that database clean of all material definitions. And it's starting in row 7. And it says if this field is empty, it's looking for the first row that doesn't have a name as the signal to quit. It's got to have a name, it's got to have a units, it's got to have 21 is Poisson's ratio, 24 is the, slide over here, is the shear modulus, and then your red, green, blue values are in 23, 24, 25. And if none of those are if all of those are not empty, then we say that that's valid definition. Let's go back to Read Materials. So we just got through down to here. So if it's a valid definition, then we're the first thing we do is check to see if that material already exists. If it doesn't, if that's false, because we're looking at the name, which you find in the current row, the first column is the name. If not, if it doesn't exist, then we're going to call add material. So we go find add material, and here's the big loader function, which is where you're going to want to tweak the order of the columns to load the various values. The key step is we define metal as a structures office.metal material, and then we create that metal material. So we dimensioned a metal here, and we create a object called metal. And metal has a bunch of operations, which include setting a string value and setting a double value. So to set the name for this material that we're just creating, we use the string name, and that comes from column 1. So if that's not empty, and it can't be because we already checked that it's valid, then we're going to load a value. If it is empty, we skip it. So if we have a family value, then we set it, and then we go on down through the form, the temper, size, spec, and then the units. We got to have a units, and it's got to be one of these two values. So when you define a material, you'll notice that there's pull downs for specific choices that you have to make, and there's range settings like red, green, blue can't be greater than 1. So it does the check for you to make sure that what you're entering is valid for that size of the field, and things like greater than or equal to 0. Let's get back to the code here. So this is where you do the addition of the material. So when you do your export to Excel, you're going to tweak these. You just got to make sure that your strings match up here, because this is what it's using to find values in that metal object. Once you're all done, you call commit, and that creates that material in the database. So what it's going to do is it loops through. It starts at row 7 because that's where I created. That's how I created the spreadsheet. You're free to create it however you wish, and so it's going to loop through, and it keeps incrementing the row, adding a material, passing in the row number, and when it's all done, it does a materials created. If there were duplicates in your material definition, it cannot do a verification. So it puts up this, the database cannot be verified for multiple entries of a material. So you don't want to do that. You don't want to have redundant entries in your spreadsheet. Then we go through the verified database. So we want to make sure that what we asked it to do, it did it. So we'll go over here to verified database, and you'll see that it, you're going row by row, and it's going to check the string value. If we go to check string value, first it gets the name of the material from that metal object that we just passed in. We passed in a metal material. First thing it does is it gets the name, and then given the value that we're after, it's going to extract that value from the metal. Then it's going to look at pull the value out of the spreadsheet for that row and column, and then do a diff on it and make sure that the value is what we asked it to make. So let's get double value. There's also get string value, which does basically the same thing. So if we go back up here to read materials, that's the head. That's the main subroutine. What it's doing is once again looking at, starting out at row 7, going through every row and verifying that what we asked it to create, it created. If it gets out without errors, it says verification complete. So that's as you see, it goes through, checks every one of the values that were input in our spreadsheet. And of course you're going to have to edit this one to match whatever you did up here, so that the columns match up. But it's pretty much just adding the fields. And that's pretty much it. Thanks for listening, and that's it for this tutorial.